Artificial intelligence, machine learning, and the Internet of Things have been growing rapidly, with the COVID-19 pandemic further accelerating their adoption across various sectors, including healthcare, education, and entertainment. ML, a key subset of AI, relies heavily on data to learn, uncover patterns, make classifications, and predict future outcomes. Thus, the quality of data, particularly annotated and labeled datasets, is critical for the development and success of ML models. Historically, data annotation and labeling have been performed manually by workers on crowdwork platforms such as Amazon Mechanical Turk, Appen, or Clickworker. However, private annotation firms have recently emerged, offering specialized data labeling services. These third-party companies employ full-time annotators and take on large-scale annotation tasks for technology clients like Microsoft, TripAdvisor, and eBay. The data annotation market is growing rapidly and is expected to reach $4.1 billion by 2024. Governments in the Global South are also recognizing the economic opportunities of data annotation. For instance, China has launched poverty alleviation programs that partner with tech companies like Alibaba and JD to provide data labeling jobs in remote areas, while India's national AI strategy highlights the importance of data labeling for employment generation. As a result, data annotation has become a central part of the AI/ML economy. There are significant differences between the work environments of annotation firms and platform-based labeling. Annotation firms employ full-time workers with fixed salaries, providing equipment and benefits. In contrast, platform-based workers are often underpaid, working under precarious conditions with no employee benefits. While third-party annotation firms require less initial capital to set up compared to platform-based labeling services, they provide additional services such as project management, quality control, and privacy risk mitigation. This makes annotation companies more attractive to data requesters, offering a better balance between cost and quality. Despite its growing market value, the human labor behind data annotation remains largely underappreciated. Thousands of workers worldwide engage in the painstaking task of reading text, viewing images and video, and labeling data to train AI systems. For instance, face recognition systems that perform well are often celebrated for their algorithmic prowess, but the essential work of labeling faces in photographs is rarely acknowledged. These tasks are often standardized across labelers, ignoring the nuances and cultural sensitivities that can affect the interpretation of data. The enforcement of homogeneity in labeling norms can result in data being labeled in ways that do not fully capture the complexity of real-world situations. In conclusion, the rapid growth of AI and ML technologies has led to an increasing demand for high-quality data annotation. While annotation firms provide a more structured and scalable solution compared to crowdwork platforms, the human labor required for data labeling remains essential for creating accurate and effective AI models. Despite the challenges of maintaining quality and addressing cultural nuances in the annotation process, human resources play a pivotal role in enabling the development of sophisticated AI systems. The demand for data annotation has significantly increased as AI and machine learning technologies continue to expand. Data labeling is a fundamental step in training high-performance AI models, and as the variety of AI applications grows, so does the need for more precise and large-scale data labeling. This increasing demand for data annotation is driven by several factors, which are critical for the success of modern AI projects. Why data annotation matters. Data annotation forms the cornerstone of building effective AI systems. At its core, AI is about teaching machines to recognize patterns and make predictions based on large amounts of data. For AI to function properly, this data must be labeled accurately so that the machine can understand the context of the information it processes. Without this labeled data, AI models cannot learn in a meaningful way, making data annotation an essential step in any AI project. As AI systems evolve, the demand for precise data annotation grows, especially in industries like healthcare, autonomous vehicles, and e-commerce. The ability to annotate data accurately and consistently directly influences the performance and success of the AI models trained on it. When the data is properly labeled, AI can provide more accurate predictions, uncover hidden insights, and automate processes that otherwise would require human intervention. Inaccurate or inconsistent annotations, however, can result in flawed AI models that misinterpret data, make biased decisions, or fail to function as intended. Data annotation not only enhances the training of AI models but also influences the overall outcomes. Whether it's text, images, audio, or video, the quality of annotations determines how well the AI system generalizes and adapts to new data. As AI continues to permeate various sectors, investing in high-quality data annotation is essential for developing reliable, fair, and effective AI applications. Role of data annotation in training AI models. Data annotation plays a pivotal role in training AI models, serving as the bridge between raw data and meaningful insights. Through meticulous labeling, data annotation allows machines to learn from examples, enabling them to identify patterns and make informed decisions. Here are some key aspects of the role data annotation plays in training AI models. Training machine learning models relies heavily on annotated data. For supervised learning, where the model learns from labeled examples, annotated datasets are essential. These datasets guide the learning process, allowing the model to understand the relationship between inputs and expected outputs. Without precise annotations, the model may struggle to learn effectively, leading to suboptimal performance. Data annotation not only provides the necessary labels but also determines the model's ability to generalize. For example, in image classification tasks, annotated images with diverse labels help the model learn to recognize objects across different contexts, enhancing its robustness. High-quality data annotations directly contribute to the precision of AI models. When the data is labeled accurately and consistently, the model can make more precise predictions. In contrast, ambiguous or incorrect annotations can mislead the model, resulting in errors that propagate throughout the learning process. Precision is especially critical in applications where accuracy is paramount, such as medical diagnostics or autonomous driving. Ensuring that annotations are detailed and reflective of the real-world scenarios the model will encounter is essential for achieving high performance. Data annotation provides context that helps AI models comprehend the nuances of the information they process. For instance, in natural language processing, annotations may include sentiment labels, entity recognition, or part-of-speech tagging. These annotations enable models to understand language context, improving their ability to interpret and generate human-like text. Moreover, contextual annotations facilitate better performance in complex tasks. For example, image data annotated with attributes such as color, shape, and size allows models to discern not just what objects are present but also how they relate to one another in a scene. In an ever-evolving data landscape, continuous learning is vital for AI systems. Data annotation supports this by allowing models to be updated with new information. As new data is collected, annotations can be added or refined to ensure the model remains relevant and effective. Continuous learning also involves retraining models with updated datasets. High-quality annotations are crucial during this process to prevent the introduction of biases or inaccuracies that could degrade model performance. By maintaining rigorous annotation standards, organizations can ensure their AI models are capable of adapting to new challenges and opportunities. The importance of scalability in AI data labeling. As artificial intelligence continues to expand and evolve, one of the fundamental challenges for organizations is the ability to scale their data labeling processes effectively. Scalability in AI data labeling refers to the capacity to efficiently increase or decrease the amount of data that needs to be labeled in response to changing project requirements or larger datasets. This flexibility is crucial in ensuring the sustained performance of AI models as they grow in complexity and application. AI models rely on vast amounts of annotated data for training, and as projects progress, the data requirements can grow exponentially. Without scalability in data labeling, organizations face the risk of being unable to manage these large datasets effectively, leading to delays in project timelines or insufficiently trained models. A scalable data labeling operation ensures that an organization can handle both small datasets in the initial stages of development and large, complex datasets during later stages of model refinement. The ability to scale not only ensures that data is processed efficiently but also helps optimize the cost of labeling. Outsourcing data annotation to scalable platforms allows businesses to adjust their workforce to the size of the data, keeping costs in check while maintaining the quality of the annotations. A significant challenge when scaling data labeling efforts is maintaining high-quality annotations. As the volume of data increases, there is a risk of errors and inconsistencies in the labeling process. This is especially true if the annotation process is not properly managed or if there is insufficient oversight. By working with a scalable workforce, organizations can employ a larger, more diverse team, which helps reduce the likelihood of bias, errors, and inconsistencies in the annotations. With proper management, scalability ensures that the labeling process can be expanded without sacrificing accuracy, a crucial factor for successful AI model development. AI projects are often time-sensitive, and the ability to quickly scale up or down data annotation resources ensures that project timelines are met. When data labeling needs increase rapidly, such as when new data sources become available or when a model requires additional fine-tuning, the scalability of data annotation operations becomes critical. A flexible, scalable approach allows an organization to adjust the resources dedicated to data labeling in real time, ensuring that delays in data preparation do not hinder the overall AI development process. In addition to improving workflow efficiency, scalability in data labeling allows organizations to optimize resource allocation. When dealing with fluctuating data volumes, having a scalable workforce enables businesses to allocate resources dynamically, ensuring that both time and financial investments are spent wisely. For example, when a project requires large-scale annotation for short periods, organizations can ramp up resources without the need for long-term commitments or increased overhead. This level of scalability offers substantial cost savings while maintaining the quality and speed of the annotation process. Challenges in data quality. Data quality plays a crucial role in the success of AI projects, and one of the biggest challenges in AI data labeling is ensuring the accuracy and consistency of the annotations. The following factors are central to understanding and overcoming data quality challenges. Data drift and anomalies. Data drift refers to the gradual change in the statistical properties of the data that AI models are trained on, which can lead to models becoming less accurate over time. Anomalies, on the other hand, are sudden, often unexplained changes in data patterns that can disrupt model performance. Both data drift and anomalies are common challenges in AI data labeling. If these changes are not properly addressed, they can lead to significant degradation in the model's accuracy. Implementing robust quality assurance processes is essential to manage these challenges. This may include techniques like sampling subsets of the data, establishing gold standards for annotators, and monitoring changes over time to detect drift early. Additionally, employing multiple annotators for each data point helps to reduce the impact of anomalies and ensures that the labeled data remains as accurate and reliable as possible. Annotation errors and inconsistencies. Annotation errors are another common problem, particularly when dealing with large datasets. Even slight inconsistencies in labeling can lead to serious consequences in the final model's performance. These errors might occur due to human factors such as fatigue or misinterpretation, or technical issues related to the annotation process itself. To mitigate this, continuous training of annotators, clear guidelines for labeling, and quality control procedures, such as having multiple annotators review the same data, are crucial. Furthermore, advanced techniques like automated checks for consistency across datasets can help identify discrepancies before they impact model accuracy. Maintaining consistency across annotators. Consistency in annotations is another key challenge, especially when multiple annotators are involved in labeling large datasets. Variations in how different annotators interpret and label data can lead to inconsistencies that reduce the overall quality of the labeled dataset. Implementing standardized annotation guidelines, providing regular feedback to annotators, and using automated tools to track annotation patterns can help ensure a more consistent approach. Additionally, regular cross-checking and consensus building among annotators are vital to ensure that the labeling process remains uniform and reliable. Data bias and diversity. AI models are only as good as the data they are trained on. If the data used to train an AI model contains biases or lacks diversity, the resulting model may exhibit biased behaviors or make inaccurate predictions. Data bias can have serious implications, not only for the performance of AI models but also for the fairness and ethical considerations surrounding their deployment. Data bias occurs when the data used to train an AI model does not represent the entire spectrum of the target population or data types it is meant to capture. There are several types of data bias that can affect AI performance. Selection bias. This occurs when certain groups or data points are underrepresented or overrepresented in the dataset. As a result, the model may learn patterns that do not apply universally or fairly. Measurement bias. This type of bias arises from inaccuracies or inconsistencies in how data is collected or measured. Measurement bias can distort the quality of the annotations and, by extension, the predictions made by AI models. Historical bias. When an AI model is trained on historical data that reflects past inequalities or biases, the model may inadvertently perpetuate these biases. For example, training a hiring algorithm on past recruitment data that favored certain demographics can lead to biased decisions. Data bias can stem from various sources, including but not limited to skewed data collection. If the data collection process inadvertently favors certain groups or conditions, the resulting dataset may fail to accurately represent the target population. Human bias in annotation. Annotators, like all humans, bring their own biases to the task of labeling data. This can lead to unconscious biases being embedded in the dataset, particularly in cases where the annotator's experiences or backgrounds differ from the target population. Incomplete or unbalanced datasets. When the data used for training is incomplete or fails to include sufficient diversity, the model trained on that data may lack the generalization capabilities needed to make accurate predictions across different contexts. Most organically produced datasets are biased except those generated by carefully designed randomized experiments. Data bias can significantly impact the fairness and inclusivity of AI models. If certain groups or perspectives are underrepresented in the data, the model may perform poorly for those groups, leading to unfair outcomes. This is especially concerning in high-stakes areas such as healthcare, criminal justice, or finance, where biased models can perpetuate societal inequalities. To address these challenges, it is essential to ensure that data labeling processes are carefully managed and that biases are actively identified and mitigated. This requires not only diverse and representative datasets but also careful consideration of the methodologies used to annotate data and the guidelines followed by annotators. Why a large workforce is essential for data annotation. Working with large datasets is critical for the success of complex AI models. Utilizing data labeling services enhances project outcomes by streamlining the annotation process. By outsourcing data annotation, organizations can manage large datasets more effectively, leading to improved model quality. Professional annotation services provide flexibility and speed, quickly adapting to the changing needs of AI projects. Here are some key benefits. Faster turnaround. Outsourced teams often complete annotated data 50% faster than in-house teams. Error reduction. Outsourcing can reduce errors in data by up to 40%, thereby increasing the reliability of machine learning models. Cost efficiency. Data labeling from external services can cut costs by as much as 60% in AI projects. By outsourcing, organizations can focus on enhancing AI capabilities rather than handling data management, which allows projects to remain robust and flexible. External experts ensure data security and compliance, enabling in-house teams to concentrate on their core functions. Outsourcing data annotation not only boosts efficiency in AI projects but also enhances model quality. Choosing the right partner can lead to increased productivity and innovation, resulting in AI solutions that stand out for their sophistication, ethical considerations, and cost-effectiveness. In conclusion, the development of effective and fair AI models depends significantly on the quality and scale of the data annotation process. As AI continues to penetrate various domains, the need for large, diverse, and accurately labeled datasets has never been greater. However, achieving the required scale and precision in data annotation is not a trivial task. It demands substantial human involvement at every stage. Despite the growing capabilities of automation and machine learning techniques, human input remains irreplaceable in ensuring the accuracy, consistency, and ethical integrity of annotated data. A key reason for this reliance on human resources is the complexity and nuance involved in interpreting and labeling data. While AI systems can handle basic tasks like object recognition or sentiment analysis in structured environments, they often struggle with the subtleties of human judgment, context, and ethical considerations. For instance, understanding cultural contexts, recognizing biases, and ensuring fairness in labeling require human insights that machines cannot yet replicate. Moreover, scaling data annotation efforts to match the increasing volume of data required for training modern AI models is another challenge. AI models need vast datasets to generalize well across various real-world scenarios, and these datasets must be carefully labeled and verified for accuracy. Outsourcing data annotation to a large, diverse workforce allows organizations to handle these enormous datasets more effectively and quickly, ensuring that their models can be trained in a timely manner without compromising on quality. Furthermore, as the data landscape grows increasingly complex, the diversity of input from multiple human annotators becomes critical in preventing biases from influencing the final dataset. Biases in data, whether intentional or unintentional, can lead to discriminatory outcomes, which can undermine the fairness of AI systems. A larger and more diverse workforce ensures that different perspectives are considered during the annotation process, mitigating the risk of reinforcing existing inequalities or misrepresentations. In conclusion, human resources are indispensable to the data annotation process, not only because they help ensure accuracy, consistency, and fairness, but also because they provide the scalability necessary for managing large datasets in a dynamic environment. As AI systems continue to evolve and become more integrated into society, the importance of a vast, skilled, and diverse workforce in data annotation will only increase, providing the foundation for more reliable, ethical, and impactful AI technologies.